So, today we're looking into the chain rule. Chain rule used to find derivative of the composite functions. Reminding that the composite function is a function of the function. So we can write composite function in two ways. Either function of a function, f of g of x, or we can write f like small circle g. Those are equivalent notations. Example, if we have 3x squared minus 2x plus 1 in the power of 5. This is a composite function, because we have not one, we have two functions here. We have g of x equal 3x squared minus 2x plus 1. And we have function f, which is equal g in the power of 5. We have function, because put in the power of 5 is a function. But we don't put x in the power of 5. We put another function. So we have function of a function. It's called composite function. So how we differentiate composite function? How we differentiate composite function? The derivative of dy over dx equal derivative of external function over df over dg times dg over dx. We multiply derivatives. So we find in derivative, we have, this is an internal function, g of x. External function is f equal g in the power of 5. So we find in derivative of the external function and multiply it by the derivative of the internal function. Let's apply it to this case. What is dg over dx? What is dg? 6x minus 2. What will be the derivative df over dg?
5
5g
times all that.
So we will have, it will be equal 5g in the power of 4. That makes sense? If we differentiate g in the power of 5, 5g in the power of 4. But then we need to substitute instead of g,
The derivative.
it's which derivative?
I don't know.
G is
Yeah.
this.
Yeah.
Where is derivative here? We already take derivative equal 5 times 3x squared minus 2x plus 1 in the power of 4. And the final answer, we multiply them, dy over dx. We multiply derivative of this, 5 times 3x squared minus 2x plus 1 in the power of 4 times 6x minus 2. We can take 2 as a common factor. So we'll make it 10. And we have 3x minus 1. That will be derivative of this function. That will be derivative of this composite function. So we find the derivative of the internal function over x, and then we find the derivative of the external function. And overall derivative, we multiply them. Make sense?
I'm just a little bit confused. How did you get to the 10 times?
Because we have 6x minus 2 equal 2 times 3x minus 1, just factorized. 2 out, 2 times 5, 10.
And you multiply that?
And we multiply this
Yeah.
by this. Couple more examples. let's consider the next function. 5x cubed minus 2x squared plus x minus 1 in the power of 7. What will be the derivative of this function? Let's say this is y equals dy over dx. We derive the x will have 7 times 5x cubed minus 2x squared plus x minus 1 in the power of 6 times the derivative of what is in the bracket. So times 15x squared minus 4x plus 1.
Wait, I got everything. Why did you add the last bracket?
This one,
Where's that from?
this is derivative of what, because we have function, we have internal function g
We
of
get
x.
expected to do this without a calculator to like
Yeah.
simplify it.
No, this is the answer.
Alright.
Now, if there is a, like in the previous example, there was an obvious common factor, yes, you take it out. But you're not supposed to do anything here.
I'm confused how you got 15x. Like I understand that's
How,
the
what is derivative of this? What is derivative?
that, but why do you put it there?
So that's how it works.
Because the rule of the differentiation, when you have function y, again, if we have y equal f of g of x, we have function of function. Because we have function, because in the power of 7 is a function.
Yeah.
But it's not x in the power of 7, it's another function in the power of 7. So when we have function of the function, do you understand that it's function of the function?
Yeah.
Then the derivative dy over dx will be equal df over dg, when we consider this as, so that will be, we can write g in the power of 7. This is g, and times the internal function over x. That is called chain rule.
This is chain differentiation of and composite functions together.
What does it give us? What does it give us?
It gives us derivative of this function.
Oh,
It's
so
derivative
on the
function.
composite function.
This derivative of the composite function. Another example. Another example. We will use one derivative that we're not supposed to learn, but we all this year, but we already talked about that. Remember what is the derivative of sine x? It's cos x. That you will learn next year. But let's consider now function of function of function. We will have triple. So we will have f of g of h of x.
Oh, that's so easy.
So, example, we have find the derivative of sine of 2x squared minus 5x in the power of 3. So we have three functions here.
What are they?
What is the most internal function? So we have h of x equal 2x squared minus 5x cubed. What is g of x?
Not 5x.
No, not 5x.
Sorry, minus 5. So yeah, sorry. My 5x. What is g of x? h cubed. And what is f f g of h, and f of g equal sine g. We have function of a function of a function. And so we need multiply all three derivatives. What is derivative h dash of x? What is this? 4x minus 5. What is derivative of g dash of h? 3h squared. And what is derivative f dash of g? Equal cos g. Let's put it all together. Let's put it all together. We will have that dy over dx. If this is y, so dy over dx equal cos, and will be cos of the whole thing, cos of 2x squared minus 5x cubed times 3h squared. So times 3, 2x squared minus 5x squared, and times the last derivative 4x minus 5. That will be the derivative of that composite function of a function of a function.
That's easy. That makes sense. Yeah. That's it.
You will not have this year like triple those function. Next year you will.
So we get to like this in the test or not? I think
As I'm saying, with a triple function of a function, no, but function of a function,
Yes.
you will have.
Wait. Can you do that again? That step?
Which last step? I put this because that will be equal
Don't drink sauce.
h dash of x times g dash of h times f dash of g. We multiply all three to get derivative of the whole function. We multiply all these three derivatives.
So how did 2x squared minus 5x get there? Because that's not the derivative.
Because it's the derivative of like.
Sorry,
So you keep
it's
the
for
original.
no.
Like,
This is f dash of g. Where this is g. This is g dash of h.
Yeah.
And this is h dash of x.
Understood.
Make sense?
Yes.
For sure.
That's how you derive composite functions. You multiply derivative of the internal function by the derivative of the external function. That's the last bit of the differentiation for this year before the SAP. So like, subscribe and donate to help fight terrorist countries and organizations, Russia, Iran, Hamas, etc. Support Ukraine and Israel.